good evening. My name is Abinesh Pillai and I'm Murugesh, matrix number CN200126. So my project proposal title is Force Feedback Finger Glove System for Hand Function Assessment. My supervisor name is Dr. Ilina Jaimi binti Muhammad Nordin. I am a semester 1, session 2022-2023 student. So next I'll be talking about the presentation contents in my slide. So I'll be talking about chapter 1, introduction, chapter 2, literature review, chapter 3, methodology, and chapter 4, expected results. So in chapter 1, I'll be talking about background of study, problem statement, objectives, scopes, and project significance. So in background of study, stroke is the second leading cause of mortality and the primary global cause of disability. According to the Global Stroke Fact Sheet published in 2022, the lifetime risk of having a stroke has climbed by 50% in the previous 17 years, with 1 in 4 individuals now thought to have stroke in their lifetime. Stroke incidents have increased by 70% since 1990 to 2019. Stroke mortality have increased by 43%. Stroke prevalence have increased by 102%, and disability adjusted life years have increased by 143%. Stroke rehabilitation may be a restorative process that seeks to push recovery, with physical therapy taking part in significant role. Following a stroke, motor impairment in the hand is common. 1/3 of stroke patients experience wrist and hand contracture, which is loss of passive joint range of motion in 6 months after a major stroke, and more than half of those with hand impairment never regain function. Losing the ability to move your hand normally is debilitating and can last for many years. The importance of collecting real-time data of patients' grip and pinch strength is still a problem. At the completion of each rehabilitation exercise, the therapist may gather the patient's grip and pinch strength data. The therapist could not collect or monitor data of patient's grip and pinch strength while the patient is still doing their rehabilitation exercise. Our main goal is to develop a wearable force feedback glove system for hand function assessment. This device is aimed to provide flexion and extension force of thumb and index finger data while doing the rehabilitation exercise. Next is problem statement. So number 1, assessment of patient strength improvement usually done by using pinch meter. Therefore, patient cannot monitor strength while doing exercise. They can measure the strength using manual tool after the exercise. Number 2, from previous studies, several robotic gloves with sensor built-in has been developed. The robotic gloves were used to collect strength data of subjects. Nevertheless, the robotic glove was uncomfortable to wear by subjects due to bulkiness of the sensor used. Number 3, in addition, the robotic glove with sensor built-in from previous studies does not have application or system to save the collected data. It is also unable to retrieve collected data from previous studies or rehabilitation session to review or compare patient strength progress by therapists. And lastly, the robotic glove with Force Sensitive Resistor, which is FSR, built-in from previous studies shows patient grip or pinch strength is resistant. There are no software or system that has been created to convert the resistance value to Newton. Next is the objectives. The objective of the project are as in the following: to develop force feedback sensor finger glove for evaluating subjects' pinch strength during finger therapy, to develop IoT application for force feedback monitoring, and lastly, to analyze the performance of force feedback finger glove by comparing the force measurement from the glove with the manual force measurement device. The scope of this project are as the following: the Arduino microcontroller will process pinch force from force feedback finger glove. The flexion and extension force of thumb and index finger will be measured. And lastly, the force feedback sensor finger glove will be tested in healthy subjects. The significance of this project is as the following. This study is necessary because it can help rehabilitation therapists and patients to review, monitor, and record pinch strength data while the patient is doing their rehabilitation exercise. If this project is a success, this project can be further developed to make it easier for the stroke patient to perform rehabilitation exercise and monitor their progress at home. So next, I'll be explaining about chapter 2, which is literature review. So in this chapter, I'll be talking about literature review of previous research and table of comparison of previous research. So number 1, I'll be talking about sensor and force feedback exoskeleton, which is safe robotic glove. It has been developed in 2015 by Pinhas Benziv and Zomau for developing a sensing and force feedback exoskeleton safe robotic glove, which was a new haptic device that is designed to gather kinematic and force information. So number 2, design a wearable FMG sensing system for user intent detection during hand rehabilitation with a soft robotic glove. So this previous study was developed in 2016 by Hong Kai Yap, Andrew, James, Go, and Cheng Hua Yu. And their design of wearable feedback system based on force myography, which is FMG, for user intent detection during hand rehabilitation with a soft robotic glove. An adjustable tight form fitting Velcro strap with the three force sensitive resistor sensors were developed to capture signals from three major forearm muscle groups. The third one is design a grip strength measuring system using FSR and flex sensor using SVM algorithm. This project was developed in 2021 by Soli Matthew Biju, Hashir Zahid, Muhammad Farid, Farhan, and Alison Bell. They have designed a grip strength measuring system using FSR and flex sensor using SVM algorithm to evaluate the condition of the hand. And lastly, novel example sensorized glove platform for comprehensive hand function assessment by using inertial sensor and force sensing resistor. So this project was developed in 2020. It was developed by Bo Xing Ling, Ai Ju Ling, and Jia Long Cheng. They developed a sensorized glove that is built and uses 9 axis inertial measurement units and force sensing resistors to monitor the force at the fingertip and the kinematics of the hand in the same time. Next, I will be talking about the comparison of previous research. So number one, the sensing a force feedback exoskeleton safe robotic glove. So the advantage are small thickness sensors are used, and also the glove is flexible to be wet, and the components are flexible to be used. The disadvantages are the result varies significantly. Calibration process is difficult, and also the Velcro strap may lose fitting, and there are no IoT monitoring to monitor the data. So number two, design a wearable FMG sensing system for user intent detection during hand rehabilitation with a soft robotic glove. So the advantage are small thickness sensors and also comfortable to wear. The disadvantage are they are also using Velcro strap that may have loose fitting, and they are not also using NA IoT monitoring. The third one is design a grip strength measuring system using FSR and flex sensor using SPM algorithm. So their advantage are flexible and using small thickness sensor. The disadvantage are no IoT monitoring and not comfortable to be wear because of bulkiness of their circuit in the glove. So number four is novel assembled sensorized glove platform for comprehensive hand function assessment by using initial sensor and force sensing resistor. So the advantage is only one, which is comfortable to wear, but the disadvantage are two, which is occlusion and time-consuming calibration and no IoT monitoring. So next, I'll be explaining chapter 3, which is methodology. So in this methodology, I'll be explaining the project flowchart, block diagram of the system, data glove design, schematic circuit, the flowchart of the operational system, and also the monitoring system mobile application. So this is my project operational flowchart. So I have begun with doing the literature review. Then I proposed my title of the project, which is Force Feedback Finger Glove System for Hand Function Assessment. After proposing it to my supervisor, I'll be accepting whether my supervisor will be approved or not. If approved, then I will do the research for suitable hardware and software component. Then we'll get pinch force data using pinch gauge, and also start assembling the circuit. After assemble the circuit, I will also develop program codes for the circuit to run. If the system data is accurate with the pinch meter gauge value, so I will proceed to develop mobile phone application. After developing the mobile phone application, I will start to establish Wi-Fi connection, and then I will evaluate the monitoring performance on the application. And if all is okay and good, it can be proceeded. I will collect and analyze data, and if there is anything that I can improve in my project, I will improve the system, and that's all. Block diagram of the system. So this is my block diagram. So if you can see, I'll be using 4 FSR sensors and also an Arduino Nano. So there will also be a ESP8266 serial Wi-Fi module, and there will also be a LCD screen and also external power supply to power the Arduino Nano. So the FSR sensor will take 4 analog input in the Arduino Nano, and and also the ESP8266 will take the digital output and also the LCD screen. So this is my data glove design. So this is the placement of my FSR sensor in the hand of the user. So there will be 2 FSR sensor on the index finger, thumb, palm, and also at the top of the index finger and hand. So the FSR sensor will be connected to the Arduino Nano, and the Wi-Fi module will connect to Arduino Nano, and also There will also be an on-off switch to on and off the microcontroller and also there will be a power supply, and also there's also be LCD screen to display the monitored data on the screen. This is my schematic circuit. As shown here, I use Circuito.io to build the circuit. So next, I will explain the flowchart of the operational system. So from start, I will turn on the switch. Then all of the 4 FSR sensors will read. If each of the sensor have reading, it will progress to the conversion raw FSR value to Newton, because FSR sensor value will be in resistance. So I need to convert the resistance value to Newton. Then I will transmit the force data to display in LCD screen. After displaying LCD screen, I will be establish Wi-Fi connection and transmit the force data to web server via Wi-Fi to mobile application. If everything is good and okay, we can turn off the switch to end the progress. If not, we can start over from the beginning. Next, I'll be talking about the flowchart of the operation system. So this is the operation system flowchart for monitoring system in the mobile application. So firstly, we need to analyze the Wi-Fi connection in the application. Then analyze the parameter for user ID login. So user need to use their user ID and the password to login. After that, the MIT software on mobile phone receive data from web server. We can also display data on the mobile application through MIT Inventor software. And lastly, we can also store on the mobile application. So this is my example of the monitoring system of mobile application. This is how it will look, the application when it's completed and run in the phone or mobile smartphones. So firstly, in the right, we can see how the user login page will look. So user need to use their user ID and also password to login. Then the second, we can see how the home page will look. So in the home page, the user can see their user ID and name displayed, and there will also be 2 buttons to connect and refresh, and there will be 2 indication: green light for connected and red light for disconnected. There will also be real-time monitoring and history pages. So the third one, we can see the real-time monitoring page. So there will be a graph which can show the force value and also the time the pinch or data has been recorded, and also the data from this session or rehabilitation session can be recorded. And lastly, we can see the table in the history part. So the table will show the number, the date, and also the time the rehabilitation session have done. And the recorded data will show of maximum force applied by the pinch triangular, and also the minimum force, and also the average force. So next, I will explain the chapter 4, expected results. So I explaining the expected result and also preliminary results. So this is a preliminary results. This is the connection that I did so far using one FSR sensor and Arduino Nano. This is me giving pressure on the FSR sensor, and this is the value that I get in Newton when the FSR sensor is given pressure. As you can see, the higher the pressure applied on the sensor, the higher the Newton value of force is. So this is the list of reference that I used to done my proposal, and this is my PSM1 Gantt chart. So for FIP1 briefing, it has taken for me 2 weeks. Then discuss project title with supervisor also 2 weeks. Then for doing chapter 1 and chapter 2, it has been taken me from week 3 to week 11. Then methodology and expected result, it has taken me from week 9 to week 12. Then I have submitted the proposal to my supervisor on week 12, and I have done my correction of the proposal that has been wrong and noted by my supervisor in week 12 and 13. And finally, I have submitted the proposal, slide and presentation video on 14th week, and present the proposal to panel on the 14th week also. So I have met my supervisor from week 1 to week 13. So this is my FIP2 or PSM2 Gantt chart, or we can say as plan Gantt chart. So as we can see here, the FIP2 briefing will be done in week 1. I need to acquire the components and materials in week 1 or week 2. Collect pinch strength force data using pinch gauge on week 3rd week. I need to start to assemble the circuit in week 3rd and 4th need to be finished, and develop the program code from week 5th to week 12. So I need also to assemble the prototype of the circuit from the circuit to the glove. So I'll be doing that from week 8 to week 12. And also I need to develop mobile phone application that will be done in week 9 to week 12. And I need to evaluate monitoring performance. It will be done in week 11 and 12. I need to also collect and analyze data. It will also be done in week 11 and 12. And also the FYP2 report writing will be done in week 11 and 12. So I need to submit the report draft on to supervisor on the week 12 and submit report to panel in week 13 and present my FYP2 to the panels and supervisor on week 14. So in next semester for my PSM2, I will be meeting my supervisor from week 1 to week 13, same as my FYP1. And thank you.